In this video, we're going to discuss how to find an equation when we are given the graph of a sinusoidal function. As a quick reminder, let's recall how the basic graphs of y equals sine x and y equals cosine x appear in the coordinate plane. Figure A shows the graph of y equals sine x for one cycle beginning at x equals 0 and ending at x equals 2 pi. Note that the graph passes through the origin. It also passes through the key points pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. In figure B, we have the graph of y equals cosine x for one cycle from x equals 0 to x equals 2 pi. Let's note that it passes through the point 0, 1. It also contains the key points pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. For a strategy of choosing whether to use a cosine function or sine function to represent a given graph, I like to make my choice based on what point is plotted for x equals 0. For example, if the graph crosses through the origin, then I like to choose the sine function, y equals a times sine of the quantity omega x. If the graph is increasing through the origin, then the value of a will be positive. If we reflect this graph over the x-axis, then the graph is decreasing through the origin, which corresponds to the value of a being negative. Now, if the graph does not cross through the origin, but it instead has a y-intercept at the point 0, a, then I like to choose the cosine function y equals a times cosine of the quantity omega x. If the graph crosses through the positive y-axis, then the value of a will be positive. If we reflect the graph over the x-axis, then it crosses through the negative y-axis, which corresponds to the value of a being negative. So let's consider an example of using a graph to find an equation for a sinusoidal function. In this problem, we're asked to find an equation for the sinusoidal graph shown. The graph given has a domain of negative infinity to infinity and a range of negative 4 to 4 inclusive. We're shown the graph in the window of negative 4 pi to 10 pi on the x-axis and negative 4 to 4 on the y-axis. Now in this visible window, the x-intercepts are located at x equals negative 4 pi, x equals 0, x equals 4 pi, and x equals 8 pi. The visible maximum value of 4 occurs at x equals 2 pi and x equals 10 pi. The minimum value is negative 4 and occurs at x equals negative 2 pi and x equals 6 pi. So, in order to find the equation, let's note where the graph crosses the y-axis. As we noted prior, the sine function crosses through the origin, and since our given graph crosses through the origin, I'm going to take the approach of writing the equation as a sine function. So therefore, I'm going to seek to write the equation as y equals a times sine of the quantity omega x. So let's first identify the amplitude and then we'll identify the period. Since the range of the graph is minus 4 to 4 inclusive, then the amplitude is absolute value of a equals 4. Now, since the graph is increasing through the origin, then we know that a will be positive 4 and not negative 4. Now for the period, we observe that the graph completes one cycle from x equals 0 to x equals 8 pi. So therefore, the period of 2 pi over omega must equal 8 pi. And solving for omega, we get omega equals 1/4. Now that we know the values of a and omega, we can write the equation for the graph as y equals 4 times sine of the quantity 1/4 times x. In this problem, we're asked to find an equation for the sinusoidal graph shown, and the graph given has a domain of negative infinity to infinity and a range of negative 5/2 to 5/2 inclusive. We are shown the graph in the viewing window of negative 1 to 5/2 on the x-axis and negative 5/2 to 5/2 on the y-axis. In this viewing window, the visible x-intercepts are located at x equals negative 1/2, x equals 1/2, x equals 3/2, and x equals 5/2. The visible y-intercept is at the point 0, -5/2. The maximum value of 5/2 occurs at x equals -1 and x equals 1, and the minimum value is -5/2 and occurs at x equals 0 and x equals 2. So in order to find the equation, let's note where the graph crosses the y-axis. And since the graph does not cross through the origin, then I'm going to choose to represent the graph with a cosine function. Therefore, we seek to write the equation as y equals a times cosine of the quantity omega x. So let's first identify the amplitude. Since the range of the graph is -5/2 to 5/2 inclusive, then the amplitude is absolute value of a equals 5/2. However, note the graph has a y-intercept that is negative, which implies this is a reflection of cosine over the x-axis. Therefore, a must be -5/2. Now for the period, we observe that one cycle occurs from x equals 0 to x equals 2. Therefore, the period of 2 pi divided by omega must equal 2. And solving for omega, we get omega equals pi. Now that we've identified the values of a and omega, we can write the equation for the graph as y equals -5/2 times cosine of the quantity pi x. Now a quick note here, we could have thought of this graph as being represented by a sine function that would have a horizontal shift. However, it's much easier for us to represent it as a cosine function.